Natural language processing, NLP, is a field of artificial intelligence, AI, that focuses on the interaction between computers and human language. The goal is to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. NLP combines computational linguistics, computer science, and AI to process and analyze large amounts of natural language data. Key aspects of NLP. 1. Tokenization, breaking down text into individual words or phrases. Example, natural language processing becomes natural language processing. 2. Part of speech tagging, POS, identifying the grammatical category of each word. Example, processing might be tagged as a verb in natural language processing. 3. Named entity recognition, NER, identifying and classifying entities in text. Example, Apple can be recognized as a company and New York as a location. 4. Sentiment analysis, determining the sentiment or emotion expressed in text. Example, analyzing customer reviews to determine if they are positive or negative. 5. Language translation, translating text from one language to another. Example, translating hello from English to Spanish to get hola. 6. Text summarization, creating a concise summary of a longer text, summarizing a news article into a few key points. 7. Building systems that can answer questions posed in natural language. Example, asking a virtual assistant, "What is the capital of France?" and getting the answer Paris. Natural language understanding, Natural language understanding, NLU, is a subfield of NLP that focuses on comprehending the meaning and context of human language. While NLP encompasses a broad range of language processing tasks, NLU is specifically concerned with enabling machines to understand the intent and meaning behind the words. Key technologies related to NLP and NLU. 1. Machine learning, ML, algorithms that enable computers to learn from data and improve their performance over time. 2. Deep learning, a subset of ML that uses neural networks with many layers to model complex patterns in data. 3. Transformers, a type of deep learning model particularly effective for NLP tasks, e.g. BERT, GPT. 4. Word embeddings, techniques like word2vec or GLOVE that represent words as vectors in a continuous space. 5. Recurrent neural networks, RNNs, neural networks designed for sequence data, useful in tasks like language modeling. 6. Attention mechanisms, techniques that allow models to focus on specific parts of the input when making predictions. Important aspects of NLP. 1. Contextual understanding, understanding words based on the context in which they appear. 2. Disambiguation, resolving ambiguities in language, such as words with multiple meanings. 3. Corference resolution, determining when different words refer to the same entity. 4. Language generation, creating coherent and contextually appropriate text. 5. Speech recognition, converting spoken language into text. Use cases of NLP. 1. Customer support, chatbots, and virtual assistants like Siri, Alexa, and Google Assistant use NLP to understand and respond to user queries. 2. Healthcare, analyzing clinical notes to extract patient information, aiding in diagnosis and treatment plans. 3. Finance, automating the analysis of financial reports, news, and social media for sentiment analysis and market prediction. 4. Content moderation, detecting and filtering inappropriate content on social media platforms. 5. E-commerce, personalizing product recommendations based on customer reviews and queries. 1. Chatbots. Scenario, a customer asks a chatbot about the status of their order. NLP task, the chatbot uses NER to identify the order number and POS tagging to understand the request, then fetches the relevant information from the database to respond. 2. Sentiment analysis. Scenario, a company wants to gauge public reaction to a new product launch. Sentiment analysis is applied to social media posts and reviews to categorize opinions as positive, negative, or neutral. 3. Language translation. Scenario, a user wants to translate an email from French to English. NLP task, a translation model processes the text, understanding the syntax and semantics of the source language, and generates a coherent translation in the target language. 4. Voice assistants. Scenario, a user asks, "What's the weather like today?" NLP task, the voice assistant uses speech recognition to convert the spoken query into text, then uses NLU to understand the intent and fetches the weather information to respond. By leveraging these technologies and techniques, NLP enables more natural and efficient interactions between humans and machines, driving advancements in various industries and enhancing user experiences.